Okay, well, let's go over function values. So in the previous example we had do stuff, and you should notice that do stuff, that function returns with a value. So instead of printing it, we have return C. So whatever the result is for C, the function spits that value out when you call it. So when you have print do stuff xy, do stuff xy with x2 and y3 will go into here, into the function. Instead of a, b, we'll have 2, 3. We'll have c equals 3 times 2, d equals 2 plus 4, all times 2, and then c is reassigned to be whatever d was. I guess 12 plus the previous value of c, which was 6. So c equals 18. And when we return c, that is replacing this whole function call. So we will print 18 to the screen. So another example, if you print do stuff 2, 2, it will put 2 in for A, 2 in for B, and it will run through the whole program and return the result. Notice how we have to say print, because just typing do stuff 2, 2 will just return a result. If we to print it to the screen, we have to type print. Composition is something else that's interesting. With the do stuff function, we can call do stuff 2, 2, do stuff 2, 2. So what does that mean? So just like in math, when you have a function f of x squared, you could have f of x or something like this. You can compose your functions. So you can do that with Python functions as well. Let's think about this. So we have do stuff 2, 2. So what will that evaluate to? Well, we know that will evaluate to 16 from here. So we can replace this with 16. We have a comma, and then we have do stuff 2, 2 again. We know that that's 16. So we can replace this statement, we can think of this statement as really saying call the function do stuff, and the first parameter is going to be 16. The second parameter is 16. So this will be A, this will be B. So go to do stuff, and we'll have 16 for A and 16 for B, and that will return some C value, and that's going to be our overall value from this composition of function calls. And if you ever get confused, find something that's evaluatable. So we can evaluate this. So find something that we can evaluate and evaluate it. Find some function that we can evaluate. So do stuff 2, 2, we can evaluate that, and we will get 16. Same thing here, we'll get 16. So once we have these two values, then we can finally evaluate the whole thing. And that's the sort of method you can go about evaluating these nested or composed functions. Another important thing that we're not really going to talk too much about in this video is variable scope. So the scope of a variable in a function, for example, what does that mean? It just means that this C value here, which we define, is only defined within this function. So when you leave the function, C that was defined inside is no longer defined as whatever it was in here. So if I define my function AB, C equals A plus B, print C, when I go here and I type print C, there's an error. There is no C value because we're outside of the scope of the function. So yes, the scope of C in the function is within this. The scope of C is only within this function. But yeah, we'll come back to this idea a little bit later. For now, don't worry too much about this. There are some options that you can apply to your parameters. So say here, my function AB, we can actually assign a default value. So let's say we have a C, and we set it equal to 8 all the time. So we could say D equals A plus B plus C. And we'll print the result. And we'll print out my function. And for A, we'll do 2. For B, we'll do 5. And for C, we could write 8. What happens if we write 9, though? Let's see. We get 16. So we get 2 plus 5 is 7 plus 9 is 16. So what happened with our value for 8? Well, we can overwrite that by changing our function call, changing our parameter or function call. If we left it alone, 2, 5, our result would be 15. So it would still include the 8 as the default value. We'd have 2 plus 5 plus 8 is 15. So we can leave it alone, not include the parameter value in our call, and it'll get defaulted to 8, or we can overwrite it to some other number, and it will change our function call. And one final thing to touch on, importing, you're going to definitely use this a lot. I don't really necessarily write a lot of my own functions, but I do import a lot of from a lot of libraries that have been made by other people, such as pandas and matplotlib and other things like that, which we'll get into. But let's say that you wrote a bunch of functions in a different Python file and you want to use them without having to copy and paste. So what you can do is you can say from, let's say your Python file was called myful. Let's just make it. Let's go ahead and make this. Let's go to the folder, new Python file, and we'll call this myfuncs.py. So this will have, let's have an add function, and we'll make this a little bit bigger. So we'll have a function here, add AB. And what did I forget? I forgot to define the function. Define add AB. And it takes two numbers, A plus B, and returns or prints the sum. Okay, so we got a function here in myfuncs. So in our other program, we can say from myfuncs import star. So what is that doing? It's saying from this program, we want to import all of the functions, and then we can use the functions. So we can say add 3, 2. And did we print? Yes, we did. So we can just call the function. It should print for us. So we get 5. So we can actually call our function from a previous program by importing it in this way. We could also just write import my functions. Problem though is in order to now call the add function, we have to initialize it with myfuncs. So we write myfuncs dot add 32. So just a little bit of a different flavor depending on how you want to do it. You can do from myfuncs import star, and then you can just call the function, or you can import myfuncs and you just have to type this before you can call your function. So for next class, read chapter 4 of the text, and I'll see you in the next video.